In this class, we're going to talk about higher derivatives. Before we delve into question, what do we mean by higher derivative? Higher derivative refers to the derivative of a function that has already been differentiated one or more times. You understand? Now this thing, you see, that explanation itself tells you something. That means that differentiating a function that has already been differentiated is what we call higher derivative. Now, there are many applications of this particular concept, so I want you to pay attention. Okay, so let's start with the first question. Let's say we are given a function y equals to 2x squared plus 2x. Now, the first derivative of this function is not called higher derivative. Why? Because the first derivative, when I define higher derivative for you, I told you that higher derivative is a function differentiating a function that has already been differentiated. That is what we call higher derivative. For example, let's say when this function is differentiated, we're going to obtain the y over the x is equal to what? 4x plus 2, right? Now, if you differentiate this function that you have here again, that is what we call higher derivative. You understand? So differentiating a function more than a single time is what we call higher derivative. You understand? The second derivative, the third, the fourth, the fifth, the sixth, and so on of a function is what we call higher derivative. Do you understand? So higher derivative in calculus, higher derivative refers to the derivative of a function that has already been differentiated. Okay, now listen. If I'm to obtain the second derivative of this function, I'm going to have the square y all over the x squared is equals to 4. That is the second derivative. And if I'm to obtain the third derivative, I'm going to have the cube y all over the s cube is equals to 0. You can see now. So now both of them is called higher derivative. You understand? Because this and this are called higher derivative. You understand what I'm saying? Because they are higher derivative by definition refers to the derivative of a function that has already been differentiated. You understand? So when you take the derivative of a function when you take the derivative of a function one time, two times, no, not one time, not a single time, okay? Now, when you take the derivative of a function twice, maybe fourth time, fifth time, those are called higher derivative. You understand? So don't forget this concept. Now, let us look at the work example as touching this. I just use this as an example. You understand? So if you are given a function, you are going to be told what you are to perform as respect to the function that you are given. Okay. For example, let's say we have y equals to x raised to the power of 3 plus 2x squared minus 4x plus 0. We are asked to find the square y. Please listen. Find the square y all over the x squared. The meaning of this is that you are to differentiate this function twice. You understand? So this that you see here is called higher derivative because we are going to differentiate the function first time and we are still going to differentiate it second time. Do you understand? The reason why I'm laying emphasis on this is because we're going to use it in application of differentiation by the time we got here. Okay, so kindly pay attention. When you differentiate this function twice, that means that you have already found what they asked you to find, the square y all over the x squared. Now, let us proceed. We have y equals to x raised to the power of 3 plus 2x squared minus 4x plus 0. The y over the x, that is the first derivative. This one is not called higher because that is the first time we are differentiating the function. Okay? Before we can say we have already taken the higher derivative of the function, at least the function must have been differentiated twice. Okay, at least. Okay, now because we are asked to differentiate the function twice, we are going to stop at the second derivative. Okay, so the y dx here is what? 3x squared plus 4x minus 4. Okay, that is not the final answer. The goal is to determine the second derivative. So the second derivative will be the square y all over the x squared will be equals to, now differentiate this function again. That will be 6x plus 4. That is the final answer. Okay, let's proceed to another question. Y equals to a a squared plus 2a plus a. Okay, y equals to a squared plus 2a. Find the square y all over the a squared. Okay, now before we can get the second order derivative, we have to first get the first order. We have to first differentiate the function once. So here I'm going to have dy over dA is equals to 2a plus 2. You understand? So the square y all over the a squared is equals to 2. You understand? That is the final answer. Okay? Are you wondering how I'm getting the answer? It is because we've learned this we have learned how to differentiate a polynomial function in our previous class. So it's not something that is strange. Okay? So what you are told to do is what you are going to do. Okay? If you are asked to find the third derivative, you still have to proceed to the cube y. Okay? Now let's proceed to another question. Let's say we are asked to differentiate t equals to t raised to the power of 4 plus 2t raised to the power of 3 minus 4t raised to the power of 2 minus 6t plus 1. Okay? We are asked to find the fourth derivative. Okay? Oh, we are having t now. Hey, sorry. Let me put y here. Okay? Let's put it. We are finding the fourth derivative. The fourth derivative of the function. You see, we are differentiating. Don't be confused that we didn't have the y dx. You understand? We are differentiating y with respect to the variable that we have here. Okay, the variable that we have here is t. So we cannot put x. Okay, so we are differentiating y with respect to the variable that we have here. Hence, I'm not going to put the y dx. Okay, find the y dt, the fourth derivative of the y dt. Now let's go. Let us start with the first one. The first derivative will be dy all over dt. Please pay attention. Will be equals to 4t raised to the power of 3 plus 6t raised to the power of 2 minus 8t raised to the weight t. Okay, this is 6t minus 6. Now, if you differentiate the constant, you're going to have 0. Now, the second derivative, the square y all over dt squared. 12t raised to the power of 2 plus 12t minus 8. Now, if you differentiate minus 6, you're going to have 0. The third derivative, that is the cube y all over dt cube. So I'm going to have 24t plus 12t. If you differentiate minus 8, you're going to have 0. So the fourth derivative is 24. No. If you differentiate 12, you're going to have this. Differentiate 12t, you're going to have 12. So the fourth derivative is 24. Do you understand how I got the answer? Okay. Now we are asked to find the fourth derivative of the function y equals to t raised to the power of 4 plus 2t cubed minus 4t squared minus 6t plus 1. Now the fourth derivative is 4 multiplied. I'm very sure you remember the basic rules of polynomial. Okay, a power rule. Maybe you missed the class, you can always watch the video on this channel. Okay, so just go through the video and learn how to differentiate using the power rule. Okay, or the polynomial rule, anyone. So I just make use of the polynomial rule to differentiate this function. So the first derivative gives me 4t cubed plus 6t squared minus 8t. Okay, minus 6. The second gives me 12t squared plus 12t minus 8. The third gives me 24t plus 12, and the fourth gives me 24. You can see now. So that is what we call higher derivative. Differentiating a function more than a single time. Okay, differentiating a function more than once is what we call higher derivative. So now let me give you just take this as a practice question. Okay, take it as a practice question. So let's say you are given y equals to 8x raised to the power of 7 plus 5x raised to the power of 6 plus 6x raised to the power of 5 minus 4 minus 4. Find so just take this as a practice question, okay? You can practice with that question. Now, drop your answer in the comment section. Now, let us proceed with how to find the derivative, higher derivative of a trigonometric function. That is what we're going to talk about in our next class, okay? We're going to look at various work examples on how to find the higher derivative of a trig function, of an implicit function. You see, what we are doing here is just the basic one. When you understand this, you can easily solve the complex one, okay? So, make sure you master what we did here, okay? Now, in our next class, we're going to talk about how to find the derivative, higher derivative of implicit function, trigonometric function, even function that that might involve various rules such as product rule, logarithmic differentiation, and other like that. Okay, so don't make sure that you don't miss the next class. So that will be all for this class. If you have any question, let me know in the comment section. Do you understand? Okay, before you go, don't forget to hit the like button, don't forget to subscribe, and don't forget to share the video. See you in the next class.